this point, you can actually turn on the recording. So I was just sharing my webcam with you guys. You can see that I am an actual real person. And after that, if you will allow me, I will turn off my camera just to share my screen, because I do believe that the overall quality of the presentation will be better that way, because I also may experience some issues with the internet connection. So let me just share my screen here. I hope you will be able to see it right away. Oh, sorry, no, this is actually the final slide. No, we will start with the first slide. Yes. So, my name is Anton Boyko. I'm a Microsoft Azure MVP. I'm also Microsoft Regional Director. You can see my email here. So if you will have any questions related to the topic that I'm presenting today, feel free to write me an email. I usually answer them quite regularly, but it can always take a few days if I'm especially really busy with my regular workload. But anyway, today we gathered with you to talk a bit about Azure App Service from the DevOps perspective. So we will talk a bit about cloud, we will talk a bit about DevOps, and we will see how those two guys are interact together. And let's actually get started. Oh, yeah, by the way, before we get started, I just wanted to ask you those two things. So first of all, if you will have any questions, don't hesitate and ask them right away. So you can raise your hand. I will take a look at the our session window just to see who was that, and I will be able to give you the voice so you can ask your question. And additionally, the thing is that I do have some questions in a kind of a quiz format. They will be in my presentation. I do have 6 of them, if I'm not mistaken, something like that. But anyway, please pay attention for those questions, because if I get it right, if you will answer the question correctly, you will be able to get something special. I'm not sure about that. This is more, like this is more like my uh, impression that I get when we talked about how we'll deliver the session. But anyway, if you'll be able to answer them correctly, at least you will be able to know that you are really learning and you really know the stuff already. So let's get started. When we are talking about DevOps, the thing is that DevOps, it's basically about everything and about nothing in particular at the same time. Because, and as this old legend goes, if you will ask 4 different blind men basically to, like get to different parts of an elephant and ask to describe what they're seeing, they will all kind of describe the same elephant, but they will describe it from the different angle, from different perspectives. The same things goes with DevOps. If you will ask someone about what DevOps is, you will get all the different kinds of answers. I'm sorry, guys. I also can hear some background noise. So can I ask everyone else to please mute yourself? In that way, it will be much easier for all the rest to follow the session. Yeah, thanks. So talking about DevOps, as I was saying, it's about everything. For example, DevOps is about development and operations collaboration. Is it true? Yes, of course, it's true. DevOps is about treating your infrastructure as code. It's true as well. DevOps is about using automation. DevOps is about using feature switches. DevOps is all about small deployments, and DevOps is also about using Kanban for your operational work. So the thing is, as I was saying, DevOps is literally about everything. To be honest, if you will take a look at the, let's say, history, how DevOps evolved, how it was born and stuff like that, you will see that DevOps is not about the technology. To be honest, DevOps, it's more about the culture, the cultural transformation, the mindset. But of course, when you get the cultural transformation and the mindset, after that, you need to support the new way of working with the technology. And today we will be talking about that part of the DevOps in particular. So let's talk about how we can enable those different DevOps practices that will help us to support basically our new mindset. When we're talking about DevOps, we can say that DevOps is about four big general areas. It's about how you plan your things, how you develop and test them, how you release or deploy them, and then how you monitor and learn them. And then based on those feedbacks from monitoring and learning, you get back to plan your new activities, develop them, test them, and so on and so forth. So it's like a circle of life. And the thing is that today we will be talking a bit about more or less all of those areas that I'm showing right now on this slide. So let's take a bit kind of a closer look at what Web Apps is, Azure Web Apps. So Azure Web Apps, it's just one of many services that you can see in Azure Cloud. But what I really like about this service is that, first of all, I do believe, and it's not only me actually, I do believe this is kind of a general opinion across the internet, is that the Azure Web Apps or the Azure App Service is the easiest service to start with. So if you don't have any previous experience with the cloud, if you don't have any previous experience with the DevOps, then working with the Microsoft Azure Cloud, Azure App Service will be the kind of a rule of thumb service to choose. You can develop your app with .NET, Node.js, PHP, Python, or Java. For example, if we will be talking about myself, then I already have a few quite big projects deployed there, and they are running that are using Node.js, .NET, and Python. Unfortunately, I don't have a lot of experience with PHP and Java, but I do believe that it should work more or less in the same way. But nonetheless, let's actually get further. And straight away, I would like to show you the architecture of the app service of the Azure Web Apps. I want to show you all the different parts, which basically altogether creates this one of my favorite services. So what do we have here? On this side, as you can see, you have your users, and your users are trying to access your web app. So first of all, they will hit the Microsoft Azure load balancer. After that, they will hit another load balancer here that is basically an IIS working in IRR mode. IRR, if I'm not mistaken, this is the application request routing, something like that. And then the request itself will hit the farm, the web farm, basically. On this web farm, what will happen? You will have like an amount of nodes here. It can be one node, two nodes, 10 nodes. It doesn't really matter. But from those nodes, you will consume mostly the CPU and the memory. And that's it. Okay, technically you will also consume the network cards, but the thing is that this web farm is entirely stateless. Because it's entirely stateless, what we can do with that and why this is important. Because as you can see, we do have an external file service here that is backed up by the Azure Blob Storage, by a very durable storage. And that basically means that each and every time I want to deploy something, I will use this deployment server here. I will deploy my code, and there are many different ways of how I can do that. For now, let's just take the easiest one, or let's say the most kind of a straightforward one is to deploy by just uploading some files on an FTP. So you will upload those files on an FTP, and they will land basically here on this file server. Then on this web form, each and every node will be connected to this file server, and each and every node will basically look at the same folder. What it actually means, it means that as soon as you update the binaries of your application here on this file server, for example, by uploading a new version using the FTP, all of those nodes here that are basically serving your website, they will see the update and they will immediately start serving new content or respond in a new way. Additionally, what we can also see on this schema is that there is an application database here, And as you can see, it's always an external database. So if you need to use a database, for example, you're deploying a CMS, and that's why you have the web app or like the app service, where you host the CMS itself, and then the content of that CMS needs to be stored in the database. I don't know, maybe you want to deploy like a WordPress or Drupal or something similar, you can do that. But again, this database needs to always be external, and you can always connect it to this web form. Additionally, what you also have here you have a small layer of basically metering, and this layer, it is connected to the runtime database. What it means? It means that the current configuration of this farm, which, for example, can consist of how many nodes are we having there, what is the size of each node, for example, how many CPUs, how many RAM do you have there, and also some configuration values, for example, some environment variables, and so on and so forth. All that data, you will store it, or like not technically you, but the Microsoft, I mean, it will store it to this runtime database. But for this runtime database, you do have an API endpoint, and you can configure it from here. Why this is important? Again, for example, let's take the case with the WordPress. Let's say you deploy a WordPress there, and let's say that you want to change the connection string for the database for your WordPress website. Why do you want to do that? There are many reasons for that. For example, you want to follow one of the security best practices, and you want to rotate your passwords even for the database. And I don't know, that maybe once per 3 months, once per 6 months, whatever, but at some point you may want just to rotate the password for your database. And let's say that, like on this picture now, you have 6 different nodes, and if you will need to go and manually update the password or any other configuration on each of those 6 nodes, you can understand that due to the human factor, you will have a huge risk of making a mistake. And if you make a mistake even in one of those nodes, your whole farm will become inconsistent. It will mean that if the request will came to, for example, this node, it will be served in one way, but if the request will came to this node, it will be served in another way, just because you kind of failed to keep the configuration consistent. To help you do that, Microsoft is given this runtime database. So what you can do, you can use this API endpoint, you can push the new configuration to this runtime database. You push it only once, creating basically an HTTP request, doing that from the portal, doing that from the CLI, whatever. You made that change once, and then Microsoft, based on data here, based on the size of this form, will populate that configuration to each and every node here and make sure that the configuration is always consistent. And also, let's talk a bit more about this guy here, the deployment server. I was talking only about, let's say, the easiest way of deploying your application using the FTP, but it's not the only one way how you can deploy that. We will talk about that a bit more later. But anyway, if you want, you can use this built-in deployment server even to run some scripts during your deployment. What kind of scripts they may be? Let's take maybe like an easiest example, the simplest example here. Let's say that you are creating your application with the .NET. If you're creating your application with .NET, that will mean that you're probably using some NuGet packages, and it is the best practice not to store the NuGet packages themselves in your repo with the source code. So this deployment server, what it can do for you, it can, for example, restore those packages for you during the deployment. Or if you are creating, I don't know, like an application which is based on Angular or React or Vue.js or some other framework like that, then you know that first of all, you also need to restore your npm or yarn or any other kind of a packages there, but also after that, you also need to run a front-end build and create basically from your source code, create basically this package that will actually serve the application. So all those stuff you can do with this built-in deployment server, which you actually get for free as a part of this entire web form. So this is basically, in a nutshell, what app service is. A little bit later, we will talk about all the different features of it. Let me just do one thing really quickly. Let me just check. Do we have any questions? I assume not, but let me just double check that. Mhm. Okay, it seems like we have no questions. I'm just trying to connect from my other device here. Yeah, seems like no questions in the chat, no raised hands. That's fine. So let's continue then. And now it's actually time for a quiz. So the question is the following. This is the first question in the quiz. Why do I need to have two load balancers that should do more or less the same job? Let me actually take you back to the previous slide. So as I was explaining, oh, wait a sec, I lose my mouse. Yep, okay, anyway, I lose my mouse for some reason, but nonetheless, as I was explaining, I do have here on the left side Microsoft Azure Load Balancer. You see this kind of first block where the first blue arrow goes. Then this is the first load balancer, and then the second load balancer is the load balancer, which is named Frontend IIS RRR. So those two guys, they are both load balancers, and it may look like to actually reach my web form, I need to pass through two load balancers. So the question is why I need to do that, because it seems kind of redundant. So let's actually, yeah, let's actually check who wants to kind of explain why do we have those. You can explain in the chat, you can raise your hand and provide me like with basically any wild guess that you can have right now. Do we have any ideas? Why is that? Okay. Yep. Okay. This probably was kind of a hard question, but anyway, let me answer this one by myself, and I really expect you guys to answer those questions in the future, because as I was saying, we probably will have something to give you as a bonus if we'll be able to answer them. So the reason why you actually need to have two load balancers here, because the first load balancer is a load balancer which works on level 4 of network infrastructure, of network protocol. And the second one is the load balancer that works on level 7. What it means that the first load balancer, it knows only about the IP address, the source and the destination IP address, and only about the port number, the source port number and the destination port number. And that's basically it. But the second load balancer, it works on the HTTP level, and the second load balancer now knows the HTTP context of the application. And there is a thing which probably kind of is still, like slowing down in some cases the overall adoption of web all across the world. But anyway, this ugly thing that's called the sticky sessions. So what the sticky sessions means, that basically means that if you were developing the web application before, you probably know that there are different ways how you can, for example, store some kind of a values, some variables, some content between different requests that are belong to the same user. So let's say if I log into the system, I want, for example, I don't know, let's say in my e-commerce website, I want my basket to be preserved between different requests that I made on this website. And one of the ways how I can basically save that basket is to put that on a server side through my session state. The ugly thing with the session state is that by default, the session state is configured to be stored in the memory of the web server itself. And the thing is that, let me just again show you this diagram here. The thing is that here in the middle, you can see those 6 different nodes. And if I will save, let's say, the data in RAM of one of those nodes, the nodes themselves, they are unaware of each other. So the first node knows nothing about all the other nodes. Each node is thinking that this is the only one node for the whole setup. And by default, the requests will be distributed across all of the nodes more or less in, in random order. So by default, they are using the round robin mechanisms. So that basically means that each next request will be served by the next node. That basically means that from user A, the request can get to the first node, and the second request from the same user can actually get to second node or third node or any other node. And that node will have no data at all in the session state. And to fix that, there are a few ways. The first way is to enable the sticky session mode, but to make it work, you need to have a load balancer which works on level 7, or to basically put your session state in external storage. Putting your session state in external storage is not always easy, especially with some old applications. So yeah, this is why this feature, the sticky session enabled mode feature, is basically a way how you can host a really, really old, not really cloud-ready application in a cloud. And another point is, yeah, if you can avoid using sticky sessions, please do. Okay, let's proceed further. Let's talk about different app service features that can be interested to us from the DevOps perspective. The first thing is the source control integration. So you can choose your own adventure because the integration that is built in the platform itself consists of the integration with the GitHub, with the Bitbucket, with Azure repos, local Git, external Git, and even OneDrive and Dropbox. That basically means that if your source code is stored somewhere in these places, then you can integrate it with the Azure Web App, with the Azure App Service, and then each and every time you will have, let's say, a new data that were changed. For example, you will change some new files, you will push some new files to your Git repo, and so on and so forth. The Azure Web App will be able to recognize that and will be able to trigger the deployment. This is really kind of a cool feature because, as I was saying, for most of the scenarios where you need to do something really, really simple, it is possible. Of course, if you have a really complex deployment, then you probably will be unable to use this built-in deployment mechanism. But for most of the websites, I do believe that it will be just good enough. And if you need to do something a bit more fancy, if you need to, let's say, not only use the built-in pipeline in terms of the integration with the GitHub or Azure repos or something else, you can also extend that with the custom deployment script. To do that, you need to install a very, very simple command line tool to your machine. The tool is called Kudu Script. The tool is based on Node.js. And yeah, I mean, like that basically means that you need to have a Node.js runtime on your machine as well. But that's basically it. If you have a Node.js runtime, then you can just do something like npm install dash dash global and type the name of the tool, which is Kudu Script, and then you can run Kudu Script from the console. What it will help you to do? It will help you to generate the custom deployment script. If you remember what I was saying maybe like 5 minutes ago, I was saying that if you need to restore your .NET NuGet packages, or if you need to restore your npm node packages, run some builds for your Angular app, and so on and so forth, you can do that. And this is the way how you can actually do that. You can create this custom script with this tool. It will bootstrap that script for you. And on my next slide, I have just, let's say, an example of how this script look like. This is, to be honest, something that you can usually see when you're creating a bash script or when you're creating like a command line script for Windows system. In general, it looks like this. So what you can do here, you can run a commands from the command line. You can, as I can see, as you can see, as I was doing it here, you can install some additional tools if you need that. Uh, this is all possible. Of course, it may be to some degree, it may be hard, and to be honest, maybe not even necessary to master the exact command line syntax of this script. I mean, like, I can totally agree to that, but the thing is, my point here was just to show you that even if you're using built-in deployment server, uh, oh, uh, okay, someone just shared the screen and now we're seeing, yeah, let me just share my screen back. Yeah, uh, the point here was that even if you are using the built-in uh, server to customize your deployments, even for that you can also like have an additional level of control. And as I was saying, with this tool, with the Kudu script tool, it will bootstrap that script for you, so you don't need to create the whole deployment script. The usual way how I work with that is I create a default script with the Kudu script generator, and then I'm seeing basically the long text file which look like this, and then I'm just go through that text file and I'm finding the place where I need to edit something. I edit that, and that's basically it. So this is the point that I wanted to make here. And what do I have next? Hey, I do have another quiz for you guys. And I really hope that you will be able to answer this question. As I was saying, you can either raise your hand or you can just type an answer to the chat for the question, why having a CPU intensive long run and build process on top of the Kudu can kill your app. So do you have any ideas why having a long running CPU intense build is actually bad for this way of deployment? Any ideas, guys? Am I still audible? I do hope
Yeah,
that you can still hear me.
yeah,
Okay, and yeah, guys,
yeah.
you don't need to be shy. You
Can I
don't
answer
need
that?
to. Yes,
Can
go
I give
ahead,
it a
type.
try?
Yeah.
Having a CPU intensive running along build process can kill because the CPU will be loaded and the Kudu app will just fail because of the space or something.
Yes, but this is so again, you are on the right direction, but technically this is not the full answer. There is also one important part that I want you to say. So you give me a half of an answer. I just want to hear the second half of an answer.
Okay. Is it to do with the kudu? Okay, this is
Yes.
another. Okay, the kudu app is it's an independent app. So having an intensive long running building process, it can destroy it because of the runtime. The runtime can exceed. So the process will be forced to terminate.
No, it's not really true. So the thing is that Kudu, I probably need to I probably needed to explain that a bit better. But anyway, let me just rewind to this diagram here. So Kudu is a deployment server that you can see on this diagram, but technically, Kudu is still an application that is hosted on top of the same web farm that is hosting your web app. So that basically means that if you are having a really CPU intensive build, you are actually taking resources away from the web app itself. So that basically means that your web app and your build server, they are sharing the same CPU, sharing the same memory. So that is why if you're having a really intensive build, then no users will be able to use the web app because all the CPU power will be dedicated to your build process. But I do believe that we can count that as a correct answer. So, Alan, if not mistaken, that was you who gave us this
Yeah,
correct answer, yes? Okay,
yeah,
so we
yeah,
probably need to make a note that Alan answered one question correctly.
yeah,
Awesome, guys. Yeah, you want to add something more?
no. I'm
No?
okay.
Okay, awesome, cool. So let's proceed further then. So the autoscale. Oh, the autoscale, that's actually my favorite part of it because technically the whole idea behind cloud is about autoscale, or not, maybe not really the autoscale, but the whole idea of the cloud is to be able to scale on demand. I always give an example of the scale on demand when I explain something like, I don't know, let's say utilities, for example, the electricity. Okay, so when you came to your apartment, you turn, for example, your lights on, and since this point in time, you need to pay for the electricity. If you don't need the electricity, for example, if you go away to work, to school, or whatever, you turn it off because you don't need it and you don't want to pay for it. And this is, as I was saying, the whole idea behind the cloud itself. If you don't need 10 servers, for example, to serve the website because all your users are, I don't know, like they're offline, maybe they went to sleep or something like that. You can just, for example, shut down 9 of them and stop paying for them. Okay. And then as soon as the users will start getting back to your website, you will turn all those servers one by one as soon as the load will came. So this is actually the thing that Autoscale can handle for you. How it works in a nutshell, really easy. As I was saying, for example, you have just a one node and you have a small load of users, and then at some point you will have more users, so your web app will be able to add more nodes, and then you will have even more users and the web app will add even more nodes. If you remember what I was explaining when I was describing basically the architecture of the web apps, I was saying that they do have a shared file system, and the web farm itself, from the web farm, you consume only CPU and only RAM. Okay, that basically means that at any point in time, you can create a new server, or technically the Microsoft will create that server for you. That server, it will be based on the same virtual machine image as all the other servers in your web farm, and then it will be connected to that shared folder so it can start serving your website right away. This is actually why it's so awesome, and this thing works like totally out of the box. You just need to configure the set of rules based on them. The Microsoft will decide that they either need to add new servers or release some servers, because what those rules can look like. Let me just give you a few examples. For example, you can say that if the average CPU load on my web farm for the last 5 minutes went above, I don't know, let's say 70%, then I would like to add one more server to the farm. And you can have another rule for the scale down. You can say, hey, if for the last 10 minutes, for example, the average CPU load was less than 30%, then you can say, hey, I don't need actually so many servers. Can you please remove one of them from the farm? I don't want to pay for it. And all of that you can configure on a portal or using the command line or using any other possible way. And I do believe that this is really kind of one of the most powerful features of the web apps in general, just because you can configure it so easily. Okay. And now we are having the quiz again. So I was just explaining actually why the Autoscale feature is so awesome and how it can help you and so on and so forth. But there are few things, like there are few scenarios where when the autoscale can actually kill your app, or at least when the autoscale is actually not so good as you may expect. So do you have any ideas why the web app's autoscale feature can kill your app?
Can I give it a try?
Yes, please.
Okay, the web app auto scale feature can kill your app because you can request for a downgrade on the CPU or RAM, and afterwards request there'll be more requests made, and your server may be overwhelmed, and your app is going to be killed by more requests than the ones you anticipated. Actually, it
Uh,
can be overloaded. That's what I'm trying to say. When you
yeah, but
scale
I mean,
down.
like, yes, this is true. This is true. That was not really what I was expected, but I will also consider that as a correct answer. But yeah, can you think about some other kind of a scenario, or maybe someone else can actually think about other scenarios where the auto scale can actually kill your app?
Okay, can give it a try another scenario.
Yes, let's do that.
Okay, there's this scenario where you actually um, you actually stop paying for one server which was providing a specific service to your web app, and when the web app requires if someone makes the request that requires the server to respond and it doesn't respond, your app can be killed.
Okay, so technically, yeah, this is actually a good idea, but technically the thing is that you cannot scale below one server. So the minimal amount of servers that you will have is one. So you will always have at least one server. Of course, it may have not enough power to basically serve all the users, so they will expect, I don't know, like they will expect some performance degradation, but technically you cannot scale below one server. Okay, let me actually stop torturing you on this quiz and let me actually show you the answers that I was thinking about. So first of all, you need to understand that scale is really fast, but it's not instantaneous. Okay, if you scale it up, you need to wait, and in my experience, it was something about like at least 1 minute. So you need to wait at least 1 minute for the Microsoft to basically find a resources in a data center, create that virtual machine from a standard image, connect that machine to your web app, and so on and so forth. And it's 1 minute only for the infrastructure part of it, because after that we also have the application part of it. For example, how fast it will take for your application to actually like start serving the request, because maybe you have some kind of a really hard long running task that is running when your application is basically starting up. So even after the infrastructure was created, you still need to warm up your server with some, I don't know, like additional tools, techniques, or whatever. But the second part was really hard part, because it requires to, like thinking that we have not only the application. Technically, you will be extremely lucky if you will be able to host the application only without any, for example, databases or storages or something like that. Because when I was talking about the autoscale, the thing is that uh, it will scale only the web tier. Okay, so it will scale only this, let's say, front end part of it. But what will happen with the database that is on a backend? And I saw that too many times in my life, actually, that when we start, especially when we start this really aggressive scale, that we can say, for example, 5 minutes ago it was 2 servers and now it's 10 servers, because I don't know, because we do have too many users that are trying to log in to our site. You will scale the web tier, and then to your database, which basically remains the same site, you will have 5 times more connections opened. You will have 5 times more requests that will be going from the web form to the database. And in that way, by having this really aggressive scaling policy for the web app and no scaling policy at all for the database, you can actually kill by yourself your database with your web apps. And if the database will go down, then potentially all this huge web farm will be just sitting there doing nothing, because there will be no database to retrieve data. Unfortunately, it's not so easy to scale the database. It's really a complicated topic. I don't know, maybe we will talk about it someday, but definitely not today, because on this topic, I do believe we can have not only like a regular webinar, but I do believe we can have like the whole conference. Anyway, let's just proceed with our presentation for today. So the thing is that it's not about you should not use autoscale. No, of course not. Autoscale is an awesome feature and you definitely need to use it. But it's more about that you need to use your head. Okay, so you always need to think how exactly you are using those cool and nice features in the Azure cloud, because technically you can abuse them and you can make everything only worse. Let's talk about deployment slots. Also another interesting topic and really kind of a cool features of Azure App Service Platform. So when we're talking about deployment slots, the deployment slots, they are kind of, like a virtual, I don't want to use the term containers, because usually when I start using the terms like containers, people start thinking about Docker and stuff. No, it has nothing to do with the Docker. Let's just consider them as a virtual isolated, I don't know, like spots or something like that. Virtual isolated spots that you can use to host different versions of your application. Okay, so that basically means that you can have a one web form And that one web form, it can host a production version of your website, but then you're saying, hey, I want to basically reuse the same resources and I want to create a small virtual isolated part on this farm and host my test environment there or host my stage environment there and so on and so forth. The reason for you, there are few. First of all, it actually helps you to pay less because one of the things that you need to know about Azure App Service Plan is that you are not paying for the amount of websites that you are hosting there. You are paying for the size of the web form. So in my first diagram that I showed you, I had like 6 virtual servers there. So let's say that I have a farm which consists of 6 servers, and each server consists of, I don't know, let's say 2 CPUs. So in total, I will be paying for 12 CPUs. And then it's up to me to decide, do I want to host like one huge website on top of this farm, or maybe I want to host like a million of, I don't know, like landing pages, and in both cases, I will pay the same because I will be paying for the amount of total CPUs and RAM in my web farm. So that is why I really encourage you to take a look at the deployment slots because they basically cost you nothing. Additional feature that you have here is that when you are deploying something to the deployment slot, what you can do, you can actually warm up your application in advance. As I was saying before, when we were talking about the autoscale, I was saying that if your application needs some time to warm it up, if you will deploy it directly to production, then what you will do, you will actually take your production offline. But we all know that we want to follow the best DevOps practices and we all want to have a zero downtime deployment. We all want to deploy a new version of our app and we don't want users to know that at this point in time we are actually deploying something. We just want them to instantaneously switch from the old version of an app to a new version of an app. In this case, the deployment slots can help you because when you deploy something to the deployment slot, you can, as I was saying, warm it up. And when that app is ready, you can do just a virtual switch. It will take approximately like 1 second to switch the 1 second to switch the configuration within the web app itself, and then all the new requests from that point in time will be served by the new version of your application. Additionally, as you can see here on my slide, if you deployed something that was by any reason, like with some bugs or maybe wrong business logic or something like that, and you want to have a really, really easy and fast way how you can roll it back, the deployment slots also will help you with that. Because in the same way as I was saying, in the same way as you were switching from the from the old version of an app to the new version of an app, in the same way you can always switch it back. So when you deployed something, you run it on production for some time, and then by I don't know, like by any reason you realize that, hey, we actually deployed something that should not be deployed. You don't need to go there and try to fix it right away and all that stuff. The easiest way for you will be to switch the deployment slot, and then you will be instantaneously rolled back to an old version of an application. And for you, for a person, I mean, like who will troubleshoot that, it will just, like remove that restriction from you that you need to fix that as soon as possible, because you will roll back to the previous version. The previous version may be without some new features, but at least it will work as you expect, and then you will just have more time to fix the actual issue. And yeah, it actually helps you with things like A/B testing and so on and so forth. How it basically works, you have your web app, And as I was saying, within your web app, you're just creating this isolated slot. You need to give it a name. The production name is reserved for the current production slot, but all the other slots that you will be creating, you can name them any way you want. In this case, for example, I named it staging, and you deploy a new version of an app, which in our case, for example, will have not blue but green background. You deploy the green background app to your staging environment, and then you just hit the switch button, or let's say run the switch command, and they both will just switch. And now on the production, you have green background, and on staging, you have blue background. And this is available from the portal. This is available from the command line. Basically, as I was saying, any tool that you want, you can use to make it happen. And kind of a thing that we already talked a bit, but anyway, if you want to live in harmony with the rest of the world, avoid running load tests on different deployment slots of the same web app. Load testing in general is a really good practice. Again, we will not be talking about load tests today, maybe during the next conversation, but anyway, the reason why you should not run the load test on your slots is the same as with the kudu, is the same that we already talked a few times about, is because all of the web slots, all of the deployment slots, they are reusing the same infrastructure underneath. So that will mean that if you will run the load test on your, let's say, staging slot, then you will take away the compute resources from the production slot. And the users that are trying to access the current production will experience the performance degradation. So please don't do that. Okay, let's talk about another thing, which is a traffic manager. To be honest, traffic manager is not a feature of the Azure App Service. No, traffic manager is a dedicated Azure service, but still, I do believe that this is a really important part of the conversation, and we should not avoid talking about that. Just as I was saying, be aware that traffic manager is kind of a standalone service, not a built-in feature for the traffic manager for the Azure App Service. Yeah, so how it actually works? It works like this. If you have, let's say, an application that is hosted across several data centers worldwide, for example, as you can see on this diagram, you may have like one instance in North America, one instance somewhere in North Europe, probably, and the third instance in somewhere like Southeast Asia. Anyway, let's say that you wanted to host your application globally, and the reason for that is because you have users all across the world. For example, we are using Microsoft Teams right now for this call, for this webinar. So Microsoft Teams is an example of the application that is deployed globally. In each and every Azure data centers that is there, Microsoft deployed its own instance of Teams. And then what Microsoft want to do, and what you can do as well with the same technologies that they are using, they wanted to create this one domain name, this one entry point, for example, www.yourapp.com, and they want this entry point to be a single entry point for all of the instances. And then, for example, they wanted to have a rule that we will redirect you to the actual data center that is, for example, closer to you geographically. So for me, they can redirect me to one of the European data centers of Microsoft Azure. I also know that Microsoft have an Azure data center in South Africa, if I'm not mistaken. So for you guys, for example, it can redirect all your traffic to South Africa data center, and then to interconnect us together, Microsoft will use the internal network between the data centers and so on and so forth. But Nonetheless, let's actually get back to the actual topic of the traffic manager. 3 instances deployed globally, 1 entry point to be able to access any of them. And in addition to that, if one of the instances will start misbehaving, I don't know, because maybe there were some network issues in the data center. Maybe, I don't know, like someone tried to deploy something and it was bad and it killed the application in the data center or something like that. The traffic manager, what it will do, it will be able to recognize the failure in that region, in that instance of an application, and it will able to remove that application from the load balancing. So that will basically mean if it will remove the European cluster, okay, and if that will be me who will try to connect this application, then I will be forwarded either to North America or to Southeast Asia. Depends on, for example, to which area my pings are better. Technically, they will be better to the European data center, but currently it is offline, so I need to choose between those two. And the traffic manager is the service that can create this single entry point for you. And here, again, I do have a quiz. This is actually also kind of a hard one. So what will traffic manager do if you as a user will start receiving 404 or 500 HTTP status codes trying to access the web app main page, and why it will behave like that? Do we have any volunteers who wants to try to answer this question?
Can I
Yeah,
give it a try?
Alan. Yeah, go ahead, please.
The traffic manager will it will transfer you to another the, okay, the traffic manager will transfer your data to another data center, another data center to check if your page is actually available or not, from your local area to another one. Let's say, for example, here it will check if my page is hosted in the servers that are in South Africa, and if it's not there, it will transfer me to another data center. I don't know if that's correct, but giving a try.
Yeah, then thanks for this answer. So the thing is that the question itself, as I was saying, it's a bit tricky and it's really hard to answer, and this is why. So actually, traffic manager is unable to make a decision of what to do based on the experience of the end user. This is the tricky part of it. So traffic manager, it will create this single entry point for you, but in any case, traffic manager will not monitor all the traffic. Okay, but to understand whether this particular instance of my application in this particular data center is available or not, what traffic manager will do, it will use the monitoring endpoints, or like the health check endpoints. That will mean that in your application, you will need to specify what will qualify as a health check endpoint. It can be, I don't know, it can be, for example, a main page of your application. It can be one of the cases, or it can be a dedicated endpoint, something like, I don't know, /API/health check or something like that. It will be up to you to configure that when you will configure in the traffic manager. And then the thing is that traffic manager will monitor how this endpoint is behaving, and only if the health check endpoint will start to respond with something which is not HTTP 200 status code, only after that the traffic manager will make a decision that this particular instance needs to be excluded. And this is a very tricky part of it, because let's assume that, I don't know, let's assume that you have like a small e-commerce setup in Azure. Okay, and let's say that you were using the root page of your e-commerce website as a health check endpoint. And to some degree, it may look like okay, but let's say that you deployed a new version of your app, and in that new version of an app, the main page performs perfectly, but I don't know, let's say that one of the pages in a catalog of your items is broken, or let's say the login page is broken, and the login page will always throw a HTTP 500 error. Traffic manager will know nothing about that, because it will monitor only one endpoint, which is, as I was saying in my example, was the main page. What we can actually get from this, I mean, like what our learnings can be from this one. So first of all, always create a dedicated health check endpoints. One of the reasons for that is you can actually make those endpoints quite lightweight. I mean, like if you will actually measure how much resources it takes to render the HTML page compared to how much it takes to render, no, not render, sorry, to respond with just a simple JSON file, then you will see that the JSON file is probably like 10 times less resource consuming. This is the first part of it. The second part of it is that when you are creating a dedicated health check endpoint, what you can do, because you are fully controlling the code of your application, you can actually go and you can check all the dependencies, all the components that you definitely know will be used for different parts of your application. Because maybe to render your main page, your root page of your website, you don't need to, I don't know, connect to the database, or maybe you don't need to use some external payment provider or whatever. But when you are creating a dedicated health check endpoint, you can do that. You can explicitly check all the dependencies, and after that, you can say, yes, we are healthy, or no, we are not healthy. And the other thing, actually, why creating a dedicated endpoint is important, and why it is important to make it lightweight, is because the traffic manager will check that endpoint periodically. And if that endpoint will consume a lot of resources, then probably you will configure it to, I don't know, like you will configure the threshold of this check, or the timeout of this check, to be something like 1 minute, because that, as I was saying, because that API method took really huge amount of CPU horsepower to generate the response. So you configure that to be 1 minute check. That basically means that if your website will start failing, the traffic manager will know about that only in 1 minute. So that is why the best practice here is to create a dedicated endpoint, make it lightweight, and try to configure this check as often as possible. But again, as often as possible. In my case, even for the most premium clients that I worked with, 10 seconds is more than enough. I mean, like, no one wants this check more often than once per 10 seconds. Okay, so let's move further. Auto heal. This is another really cool part of the web apps. For example, if your app starts misbehaving, and if it starts misbehaving during the daylight time, then it's fine. You can get, I don't know, like an alert email or something like that, and then you can jump on it and you can start fixing it and so on and so forth. But what if your app starts misbehaving at 3 a.m.? It can send you an alert email, but do you really like to get up at 3 a.m. and try to fix something? I mean, like when you're halfway through your like regular sleep routine? I don't think that. So that is why you can use this auto heal feature to actually try your web app to recover the normal operation mode by itself without any manual intervention from your side. So how it actually look like? It looks like this. This is the screenshot from the portal from one of my websites where I actually still need to configure that feature. But anyway, so what you need to do here, as you can see, there are three key areas of the auto heal. So the first area called define conditions. You can see it more or less in the middle, and you have 4 different conditions that you can use: the request duration, the memory limit, the request count, and the status codes. So with the defined condition, you're explaining to the web app what can be qualified as unhealthy situation. So let's take it the first example, request duration. You can say that if on average my requests are taken longer than, I don't know, let's say 5 seconds or something like that, then my web app is unhealthy. The memory limit. If my web app is consuming more than this amount of memory, then it is unhealthy. The request count and the status code goes like this, that if in, let's say, last 1 minute window, I had more than 1000 HTTP 500 status codes, then my app is unhealthy. So you can configure that. Then you configure an action. So what you want to do if we diagnose, or like if Microsoft Azure diagnose that your app is unhealthy. The first one is recycle process. So you can just say, hey guys, please just reboot it, and that's it. The second one is log an event. You can say, yeah, I mean, like, this is the unhealthy situation. Please do the full log and so on and so forth. So when I will get up, I don't know, like 8 or 9 a.m. or whatever, and get to work, I will be able to check that later and try to do something to prevent that from happening in the future. And the third one is custom action. A custom action is really like any other custom action. So what you can do, you can, for example, send a webhook to another endpoint, which may be in Azure or anywhere else, and then under that endpoint, you can do basically any kind of a crazy stuff. You can reboot the web app, you can trigger the deployment in another region. I mean, like literally everything you want, you can trigger with the custom deployment. And then the startup time, here you can basically say that, okay, if my application is, let's say, if my application needs to take 5 minutes to warm up or something like that, I want to disable the auto heals from happening for the first 5 minutes when my application just started. Because otherwise, uh, yeah, it will constantly be rebooting and so on and so forth. This is really a cool feature. I encourage you to use that. And I also do have a quiz on this one for you. So why using auto heal can actually kill your app? Alan, do you want to give it a try?
I I wanted to give something like
Mm-hmm.
the auto heal.
Mm-hmm.
It can collide with the original version of the app, something like that.
Okay, can you be a bit more specific? Because I do believe that you are on the right track, but I just want to kind of double check that. Can you give more details, please?
Okay, it can the it can actually collide. Maybe let's say, for example, an app had crashed, and
Mm-hmm.
and the auto heal resolves the matter, and maybe the app returns to its state. Like maybe it was throwing a 404 error, and when the
Mm-hmm.
auto heal was resolving the issue, and the process it was healed before the auto heal took the action. So the app can collide, the
Mm-hmm.
versions can collide, and maybe the app can be killed. Is something like that.
Yep, so you're actually talking about false negative scenario. Yes, that can actually happen. Yeah, this is actually a really good scenario, but I was thinking here about a bit different thing. But I was thinking about that when you are using AutoHeal, that what I saw through most of my clients when they were using that in a huge production setups is they were just saying, hey, let's just do the reboot, and that's basically it. You know, but if you will do the reboot, and if that reboot will not fix the actual problem, then you will just end up with an infinite reboot loop. So that basically means, again, that the auto heal itself is a really, really cool feature. But again, you need to use your head when you are configuring it. Because if you're facing, let's say, HTTP 500 error, that's fine. That basically means that there used to be an internal error somewhere on your server, but if you are facing the 404 issue, for example, that may mean that actually means that the content was not found, but it can be due several reasons. For example, it may be that one of your links is broken, then it's your issue, but it also may be that someone is trying to, like type some random URL in a browser or something like that. And of course, you don't have anything which match that URL on your website, so the website will start responding with 404. And it can, to some degree, if you configure your rules like that, it can actually trigger the auto heal, and then you can end up in the infinite loop of auto heals. Okay, let's get further. Backups. Again, uh, this is actually another important topic. This is, we do have a joke here in Ukraine. I'm not sure that I will be able to translate that to English, but I will try to do my best anyway. So the thing is that there are two kinds of people over there. The first kind is those who are doing backups, and the second kind is those who are doing backups since now. Which basically means that, yeah, to really understand the necessity of doing backups, you need to at least once in your career suffer from not having those backups. But anyway, there is a built-in functionality for the backups that you can use with your Azure Web Apps, and it can backup those three things. It can backup the web application content, basically those files that are stored in your shared folder, in that shared file system that will be connected to each and every server on your web farm. You can also backup the application database. So the external database that is connected to your web app, you can also configure the engine to backup the database together with the content. And in addition, the third part, if you have some configuration And that configuration may include, I don't know, let's say database connection string, for example. This is the configuration, or any other configuration value that will be backed as well. And this is, again, the built-in feature. You can configure that on the portal. You can configure that using the command line. Everything is possible with this one. But still, I am not 100% happy with the backups. I know this is the quiz, but I will give you an answer without asking all of you to kind of try to give it a shot. And the reason for that is because we didn't really cover another important topic today, and that is why, yeah, I mean, basically, you may not be really prepared to answer this kind of a question. So the thing is that when we're talking about web app, I was saying that we do have this shared file system. But to be honest, I'm not recommending to use that shared file system for anything except the binaries of your web app. Okay? But now, except the binaries of your web app, you may also have some content, some structured content that you may store in your database. But additionally, you may have some unstructured content like pictures, video files, audio files, something like that. So back in the 90s, at least here in Ukraine, it was really popular to store your pictures in your database, in your relational database. And that was really, really kind of a dark ages for the Ukrainian IT, because there are absolutely no reasons for you to do that. So this is really, really a bad practice to store pictures, video files, and stuff like that in your database. So usually you store it somewhere else. If you are working with Azure, you're usually storing them in the blob storage, because that's basically the service that meant to handle those kind of stuff. And unfortunately, the built-in engine for the Azure Web Apps, which are handling backups, cannot back up the Azure blob storage. So as I was saying, you can back up only the content of the file system, the configuration, and the database. So that is why personally I'm not 100% happy with the backups, but still, in any way, guys, I do encourage you to not only try that, but in general, please be those guys that started using backups before they failed at least once by not having them on production. And that's basically it, what I'm having for today. Do we have any kind of questions related to the content that I was presenting today? Okay, let me actually, you know what? Let me do this. I will exit the presentation mode. I will stop sharing my screen, and I will turn on my camera so you can ensure that it's still me who was basically talking through the entire presentation, and I'm a human being. And yeah, as I was saying, guys, if you have any questions, feel free to ask them.
When are you going to have the another meeting?
When we will have the next session? Oh, Anselmo, I do believe that this is the question more to you. When we will have the next webinar?
Yeah, so actually the next webinar will be early July. Yeah, so is it, yeah, next month is tomorrow, yeah. So early July, yeah, we shall communicate and you guys will be able to RSVP on Meetup. Yeah. Yeah, any other
Awesome.
question?
Yep, any other questions?
Okay, I was having another question. Between AWS and Google platforms, which one can you what's your preference?
Okay, this is actually really an interesting question because yes, mostly I worked with Azure, and there is a reason for that. So first of all, the first thing that I wanted to say is that there are no things like best cloud for everything. Okay, I always give an example that, for example, if you will ask me which car is better, this is the wrong question because it depends on which exact scenario I want to handle with this car. If I want to drive myself to work, for example, then I will probably use some comfortable saloon and so on and so forth. But if I need to move, for example, from one apartment to another apartment, and I need to move my furniture, my computers, monitors, all that stuff, I will probably use a van. Okay, so now let's try to answer the same question, but for the cloud. The reason why I use Microsoft Azure most of the time, there are a few reasons. So first of all, the mindset of Microsoft working with creating their cloud was the following: that we want to make the complicated things easier. Okay, so that means that if I don't have, let's say, a really deep knowledge in this area. For example, I may not have a really deep knowledge on how to create a geo-distributed database. Microsoft will handle that for me. I may not have enough knowledge how to create a geo-distributed network. Microsoft will handle that for me. So this is the first reason. The second reason is that currently Microsoft provides me with the, let's say, best possible coverage in terms of regions. So currently, if I'm not mistaken, Microsoft already announced their data centers to be available in something like 60 different regions. Which for me is really important because mostly I'm worked, or at least like for the last like 3 or 4 years, I was mostly working with the public websites. So for me, that was really important that I can host my website in the same actual region where my end users will be. Because yeah, technically I used to have a really interesting project, like when the guys approaches to me, they said that we do have our website host in Brazil in one of the data centers, but our primary market is in China. So can you please help us to speed up improve the performance of the website for the users that are from China? If you'll open the map, you will see that from the Brazil to China, you need to travel half of the globe actually. And one of the things that we offer them is to use the Azure data center, to move to the Azure data center so they can still manage the users that are came into the website from Brazil, and they also can deploy the same website basically as closer as possible to the Chinese market. If we're talking about, for example, what will be the benefits of the AWS mindset was more about that if you have a lot of experience building your own data centers, then please go to AWS. So AWS have really cool features when it comes to working with the infrastructure, and most of those features came from, like basically using the same, let's say, set of techniques, or like the same tools, same approaches that you were using when you were building your own physical data center. So that is why for the AWS, it's really easy to engage, let's say, those guys who really like to work with the bare metal. For the Google Cloud was the third company that joined the race of the public cloud offers, and for them, it's really kind of a tricky, but I still do believe that the biggest benefit that they are providing, at least to me, is that if we are using tools like Google Analytics, for example, it's really easy for us to integrate data from Google Analytics, which we gathered on those public websites, it's really easy to integrate them to Google data processing pipelines. And it works super fast because the data and the pipeline engine is basically hosted in the same data center. So technically, there are no issues for me to, for example, I don't know, using something like Azure Data Factory, Azure Synapse, and a bunch of other Azure services to pull the data from the Google data center and store it somewhere in Azure, process it there, and create some Power BI dashboards. Yes, technically it is possible, but it's not always the best for the business. So currently, when I'm creating my solutions, I'm always aiming for, like multi-cloud approach in a way that we need to take the best offer from each and every cloud. But in general, always Azure will be my first option. So I will start looking at clouds like AWS and Google Cloud only when I confirmed that Azure, by any reason, cannot help me to handle this or that request. I hope I answered your question.
Yeah. Thank you for answering the question.
Okay, do we have something else? Any other questions, guys?
Any other questions? Yeah. Okay. Silence means I think there is no other question. Yeah. So
Okay.
Anton, thank you for giving out this session today. I really learned a lot. Yeah, it was really technical. Yeah, but I really learned a lot. The questions were a bit hard, but we had Alan to the rescue. Yeah, so Alan,
Exactly.
yeah, so Alan will get a LinkedIn Premium. Yeah, we shall reach out to you.
Woo! Thank you, guys.
Yeah, and maybe because you answered a lot, and maybe on MCT, yeah, voucher, yeah.
Oh, wow.
Yeah, so maybe if you cannot reach out, just send your email, the chat, then yeah.
Oh, can I send can I send my email right now to the chat?
Yeah, let's do that.
Okay. Okay. Ooh, it's been a nice lesson though.
Yeah.
Thanks, guys. Yeah. Thanks, guys. I hope that it was not only Alan and Anselmo who enjoyed this session. I hope everyone else also enjoyed the session. It was really nice presenting today in front of you, and I really hope that I will see you later when Anselmo will reach me with the, let's say, next options where we can when we can host next webinar. Yeah, I will be happy to present again.
Anselmo.
Yes.
I can't access the chat. The chat. Can I have your email? Maybe I'll send you my.
Okay, no problem.
Yeah.
You can't access the chat.
Yeah, I can't. It says
because I'm not out of the organization.
Yeah, I'm using the Chrome version. I don't have the app itself.
Oh, okay, just write anselmo.flavian@studentambassadors.com.
Okay, let me give you mine. It's easy.
Okay.
AK-Melly97.
Yes?
AK-Melly97.
AK-Melly.
Melly. AK-Melly97.
Melvi.
Melly. MELI.
MELI. Okay.
And 97 at gmail.com.
So it's AK or AM? K-Melly.
AK.
Or AK. Oh,
Yeah, AK.
AK Melly at AK Melly 97. Okay.
Yeah, AK Melly 97.
Okay, no problem.
Yeah.
Thank you.
Thank you again.
Yeah.
Okay, so then that probably will be it for today. So again, thanks everyone, and hope to see you on my next session.
Yeah.
Bye. Have a
Have
great day.
a
Bye,
nice
guys.
time. Yeah, cheers. Bye, guys. Thank you for joining. Yeah, looking forward to those Azure episodes. Yeah. From
Thank you.
from now to next forever. Bye, guys.
Hello, guys. Please don't leave. We still got some extra goodies. So,
The liquid was gonna solidify, and they were just gonna pull it out and just about everything had to swim. It was too late. The guy didn't stop him in time. The spider got from me before he could save me. Stay put.
guys, did you hear me?
Ever seen this? About the only way it shouldn't work. So it comes out with its claw, grabs it, brings it back to its lair before it slices it. Oh man, that was a strong slicer. I think that blade is a little overkill for slicing.
Hey guys, we have some MTC vouchers and other LinkedIn premium. So I think you'll just I'll share with you my Twitter profile so that you can DM me, and I think there'll be enough for everyone. We got 15, so I can see we're 12. So let me share my Twitter profile. Then just DM me and I'll share it with you. So just a minute. Okay, so there's my Twitter profile. Just DM me with your name and I'll share it with you. And thank you for being part of this epic meeting. And I welcome you to the other one come next month.